Hi everyone, so this video is going to be on the binomial theorem, and I'm going to just do some background information first that's going to help us when we actually come to binomial theorem. So we have this thing called Pascal's triangle, and as you can see here, looks a bit like a triangle. Normally we do write a 1 at the top here, but for the purpose of how we use a triangle, that's not important. But how we make the triangle is you add the two numbers above to get the number below. So these red here, do 1 plus 2 and you get the 3 here. And then 2 plus 1 gives 3. Then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. And the outside edges are always 1s. So what we can do, we can actually find the numbers within this triangle using something called combinations. And the notation for combinations is this NCR. It can be written in any of these different forms. I'm generally going to use the first one or the last one in the brackets when we are doing these types of problems. And what combinations do is this notation represents the number of ways n items can be taken r at a time. You can work this out with a formula, so it can come up in, say, non-calculator types of exams. And here is a formula. It is in the IB booklet, formula booklet, so you do have it there and don't need to remember it. So how this works is you have n exclamation mark, which means n factorial. And n factorial would be if it was 4 factorial, so 4 exclamation mark, we work that out by doing 4 times 3 times 2 times 1. And you'll see how that works when we do these first examples. Example 1, calculate the following without using your graphics calculator. So 7, 3, which means this will equal 7 factorial divided by 3 factorial multiplied by 7 minus 3 factorial. And from here we can work it out. So I'm going to do a big expanded version. So 7 factorial will be 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 factorial, which will be 3 times 2 times 1, multiplied by 7 minus 3 factorial, which will be 4 factorial. So 4 times 3 times 2 times 1. Now if we look here, because everything's multiplied, we can do some cancelling. In the numerator and the denominator, we've all got a 4 times 3 times 2 times 1. So that will cancel out. And we are then just left with 7 times 6 times 5 all over 3 times 2 times 1. And then we can work that out. Now 3 times 2 times 1 is 6, which means that will cancel with the 6 in the middle. And we are just left with 7 times 5, which is 35. B, we've got 8C5 just in a different notation. So it means our n is 8 and our r is 5. And we can do the same thing. So it would be 8 factorial on top over r factorial, which will be 5 multiplied by 8 minus 5 factorial. And then we can go from here. We can cancel, so we can actually cancel a 5, 4, 3, 2 and 1. We're then left with 8 times 7 times 6 over 3 times 2 times 1. Once again, the denominator equals 6, so we can cancel that out. And we get left with 8 times 7, which is just 56. And then the last one, C, which is 6C4, means we'll have 6 factorial over 4 factorial multiplied by 6 minus 4 factorial. If you wanted to, you could simplify this first before you start doing your multiplication. If you would prefer to just write it like that first, do your 6 minus 4 and then do your calculations, it's up to you, it's your preference. So our numerator will be 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1 and then 2 factorial, so 2 times 1. Do our cancelling, which will be 4, 3, 2 and 1. We're then left with 6 times 5 over 2 times 1, which will give us 30 over 2, which is 15. And it's that simple. We can use this to help expand binomial expressions. I've just got a little note at the bottom here. You can expand binomial expressions of x plus y, all to the power of n, using patterns, and that's known as a binomial theorem. It does link with a rule, which we'll go through soon, but I find it easy generally to look for the pattern, and I find that the best way to, and easiest way to expand. So in the first one, we've got x plus 2 all to the power of 5. Now how we do the expansion of this, we start with a combination for each term. So we're going to start with our power. So our power here is 5. So that's going to be our n, so it'll be 5. And we always start with 0, so we'll have 5, 0. Now with this, it means our first term is to the power of the top, and our second term, which is 2, is to the power of the bottom number, which is 0. And that's how we work each term out. And the next term will be 5, and this time we go up by 1, so it'll be 1. Now when we're doing this, our first term, so our x, the power of that goes down by 1 each time. So this time we had 5 before, so now it'll be 4. And the second term, which is a 2, power goes up by 1 each time. So it'll be 2 to the power of 1. So you see here we have a 5 and a 0. Then we have a 4 and a 1. The next one, our combination will be 5, 2. And then you'll have x to the power of 3 because it goes down by 1. And the second term goes up by 1. So we'll have a 3 and a 2. And you notice each time these powers always add to 5. It's a good way to have a little check to make sure you're doing it correctly. Carry on with this pattern, going down by 1 and then up by 1 with the powers. I'm just going to go to the next line to carry on. Now, when we get to this point, this is how Pascal's triangle can sometimes be quick if it's a small number like the power of 5. So what we do, we actually look in our Pascal's triangle for the 5th row. So you've got row 1, 2, 3, 4, 5. So the row with the 5 in it basically. And that is what each of our combinations equals. So 5, 0 in our combination of 5, 0 equals the first number in the row, which is 1. So this will be 1 multiplied by x to the power of 5, and then 2 to the power of 0 is just 1, so we don't need to write anything. Then the next one, 5, 1, is the second number in the triangle, which is 5. So it'll be 5 x to the power of 4 times 2 to the power of 1, which is 2. Combination of 5, 2 is the next number, which is 10. So we'll have 10x cubed, 2 squared, which is 4. 5, 3, the next number, which is 10 again. So it'll be 10x squared, 2 to the power of 3 is 8. Next one, 5, 4, the combination is the next number, so it'll be 5, so it'll be plus 5. X to the power of 1, 2 to the power of 4, which is 16. And the last one, 5, 5, is the last number in the row, which is 1, times x to the power of 0, which is 1, multiplied by 2 to the power of 5, which is 32. And then you can just simplify from there. So we'll have x to the power of 5 plus 5 times 2 is 10, so 10 x to the power of 4. 10 times 4 is 40, so 40x cubed plus 80x squared plus 80x plus 32. And so you can do these big expansions actually really, really quickly. Now, another way you can work out your combinations is using your calculator. So depending which calculator you have and use, if you are just using a normal scientific calculator, you'll find you will see the little button that says NCR. All you have to do is in your calculator, you write, if you're doing 5, 1, you'd write 5, then press the NCR button, then 1, and it will calculate it for you. If you're on the Texas Instrument Inspire, you can actually just type NCR first, open a bracket, and then 5, 1, and then that will work it out as well. So depending on what calculator you have, there will be an NCR button somewhere, or in the graphics calculators, you can often type NCR and it will recognise what you're working out. Okay, part B, got 3 minus a to the power of 6. So we're just going to use the same ideas. For working out, our power here is 6. So we'll start with 6, 0. The first one to the power of 6, the second one to the power of 0. Now we have to remember that negative in front of the a. Next one, 6 and 1. Now the 3 is going to go down by 1 in the power, so it'll be 3 to the power of 5. And then the second term goes up by 1. And we just carry on following that pattern. And there we have just written all that out. Had to go over the second line again because it was longer with it being a power of 6. So in our Pascal's triangle, we can now look at the 6th row and we know our values that will go in front of each section. So 6, 0 is 1, so it always starts with 1. Have 3 to the power of 6, which is 729. A to the power of 0 will just be 1. And then 6, 1, next number along is 6 in our triangle. 6 times 3 to the power of 5, which is 243, times negative a to the power of 1, which is negative a. And once again, just continue with the process to work it out. So in that step before, I had just made an error. This last term here should be a 6 power. I had written a 5, so I've just changed it now. And then we can just simplify each one separately for our final answer. So we'll have 729. Remember what this negative is, so we could become minus 1,458a plus 1,215a squared minus 540a cubed plus 135a to the power of 4 minus 18a to the power of 5 plus a to the power of 6. And there's our expansion. So it's much easier than writing out the bracket 6 times and trying to do FOIL a lot. It's a lot quicker. 2 more for practice. So next one, we've got 2x plus y all to the power of 4. Do our pattern. So it's a power of 4, so it will just be 4, 0, 2x to the power of 4. The second term power is always 0 in this one, so we don't actually need to write it. And then we'll have 4, 1, 2x to the power of 3. The y will be introduced. 4, 2, and then we'll have 2x all to the power of 2, and then y squared plus 4, 3, 2x to the power of 1, y cubed, and then the last one, 4, 4. 2x will now be to the power of 0, so we don't need to write that, and then we'll just have y4. And then we can simplify. So remember here with the 2x, the 2 has to be the power of 4, and the x has to be to a power of 4. So this first term will end up being 16x 4. So we'll have 16x to the power of 4 plus 32x cubed y plus 24x squared y squared plus 8xy cubed plus y to the power of 4. Then the last one, just once again, same as we've been doing previously, we just have another negative in here, which we know how to do and sort that out. So the first one, the combinations are 1. So we don't need to write it, and we know it's just going to be 3x to the power of 6, because the second term is the power of 0. Next one, the combination is 6. We'll have 3x to the power of 5, and then our negative 2y will come in. And then we simplify all of our terms. Now with binomials, sometimes it asks us just to find a particular term. So we can use this idea and this kind of phrasing here, which is what we did. We have our NCR, we have our first term, we have n minus r, the top number minus the bottom number, our second term to the power of r. Now r is our term number minus 1. So because we start as r at 0, that's our first term. So our second term is when r is 1, our third term is when r is 2. So r is our term number minus 1. So in example 3, we want to find the 7th term in 3x minus 4y all to the power of 10. And we want the 7th term. So if we were trying to find the 7th term, we know our n equals 10, because that's the power we've been given. our r is the term minus 1, so we want the 7th term, so it'll be 7 minus 1, so our r will be 6. So we are looking for the term when our combination will be 10, 6. And in that, we have our first term, which is a 3x, so it'll be 3x. And we do our n minus r, so 10 minus 6. Our b term, which is negative 4y, and that's just the power of r, which is 6. And then we can work that out. So 10, 6, put that into your calculator, you find that is 210. 10 minus 6 is 4. So we'll have 3 to the power of 4, x to the power of 4, and then we'll have negative 4 to the power of 6 and y to the power of 6. And we can simplify that. So it'll be 210 times by 81 x to the power of 4 multiplied by 4096 y to the power of 6, and simplify once again, multiply all your numbers together, and we get a nice big horrible number, which is fine, and sometimes that happens. And there's our final answer. Another way that you can be asked questions, so we have the 5th term in the expansion of ax plus byn is 560x cubed y to the power of 4. Find the values of a and b, and they must be integers. So this time we know what we're trying to get to, we just have to work out what a and b are to get to that. In this situation, we need to work out what n is going to be. Now remember what we said earlier, what we looked at, the powers in our term, because we just have x's and y, which is really easy, means they add together and they will give that power. So we have an x cubed, so we know that we're going to have a 3 and the y to the power of 4, so our n will be 7. Because in our expansion, our powers generally always add up to our value of n. Now we're wanting the 5th term, so r will be 5 minus 1, which is 4. Our combination will be 7, 4. And then we know it's going to be ax to the power of 7 minus 4 and by to the power of 4. 7, 4 is a combination. You work that out, we're going to get 35. We're going to have 35a cubed x cubed b to the power of 4 y to the power of 4. Then we know that this has to equal 560 x cubed y4. Now we've got this expansion, we can start just concentrating on the numbers. So we know that 560 has to equal 35a cubed b to the power of 4. And so 16 has to equal a cubed b to the power of 4. Now this situation here just requires you to have a bit of logic. If we've got 16, a cubed, we can't cube a number and get 16 as an answer. It doesn't work. But we can do a number to the power of 4 and get 16. Think about it, a cubed equals 16 doesn't work. But b to the power of 4 equals 16 does work, because 2 to the power of 4 equals 16. So as we've found a situation that works, this tells us that a must just be 1 and b is going to be 2, because 1 to the power of anything is just 1. So therefore our final answer would be our combination, which is 35, multiplied by x cubed, multiplied by 2y to the power of 4. And then you can expand that and check that you've got it correctly and see if it works out. And it does, so we have confirmed that a equals 1 and b equals 2. Final example. We have this expansion of x plus 1 over x to the power of 9, and we want to find the term in x cubed. So this time we know we want the x cubed, but we have to work out which term that is. The way to do that is a bit of a process, but it always works, and this is quite often how IB do ask questions with the binomials. So we know in our expansion, our n is 9, and we need to find what r is so we can work out the term number. So in this, we know it's going to be x to the power of 9 minus r. And our next term is 1 on x, so it'll be 1 on x to the power of r. Now we're wanting the x cubed. So with this, we're just looking for the x cubed. So the numbers part of it doesn't actually matter because we know we're just looking at the variable. So for x cubed, what 9r is doesn't matter. It's not going to affect the x cubed. So we just have to look at the x's. So we know our x cubed has to equal x to the power of 9 minus r. And that will be multiplied by 1 over x to the power of r. Now 1 to the power of r doesn't matter because it's just going to be 1. X is on the denominator, which means using our index laws, it will just be to the power of negative r. We can just rewrite it that way, and then we can do our index laws. Now remember, 2 bases multiplied means we add the powers. So it'll be 9 minus r plus minus r, which will give us x to the power of 9 minus 2r. Now we have a base of x and a base of x. We can forget about the x and just look at the powers. So we go to our power of 3 has to equal 9 minus 2r. If they're equal, these powers have to be equal, and we can solve this. So we'll have negative 6 equals minus 2r, 2r equals 3. Now remember, r is our term number minus 1. So 3 equals the term minus 1. Therefore, it means we are looking at the 4th term. Now, when you do questions and practice with these, that'll come a bit more fluid in its process. But it's a way that always works to work out which term you are looking for. And that is the end of binomials.